Basic measures of variation will begin our study with more of the statistical analysis and the basic one variable statistical analysis that we can run. We've talked so far about the measures of center, where the center of data is. Now we're going to talk about the measures of variation, how the data varies, how big the span of the data is, called the range, as well as the main measure of variation, standard deviation, and the two different types of standard deviation that will occur. So let's begin by talking about the range. It's something you've probably been familiar with. The range of a set of data is the difference between the highest value, which is the maximum, and the lowest value, which is the minimum. Obviously, it's a very simple formula. You take the max value, you minus the min value. The round-off rule in terms of measuring centers and measures of variation. We have a rule that we'll put in place, and it's one more decimal place than is present in the set of data. So for example, if we have data that's all whole numbers, we'll do a round-off rule in terms of the tenths place, one decimal place. In our example here, India has 1 satellite, Japan has 3, the United States has 10, and Russia has 14. We need to find the range of this data. Now, albeit it's very limited data, it's a very extremely small sample, but we can find the range of this just by simply doing 14, the highest, minus 1, the lowest, and we do put 13.0 because of the fact that with the round-off rule, doing one more decimal place than is present. Standard deviation has two different forms. The main standard deviation that we will use is the standard deviation of a sample, because it's very infrequent that we will have an entire population available for any statistical analysis. Standard deviation is symbolized by S when it's a sample, and it's the measure of the variation of values about the mean. The value of S, the standard deviation, will 99.9% of the time be positive. It will absolutely never be negative. And it only can be 0 when all of the values in your data set are the same, which obviously is very infrequent as it is. And of course, the S value can increase dramatically or decrease dramatically with the inclusion of any of outliers. It will usually increase due to the fact that the outliers are put in. When you take outliers out, it'll decrease the value. However, when you're taking outliers out, now you're creating a possible bias. The units for the standard deviation are always the same as the units that we are working with in the original data set. That's a key point to remember, that the units will always be the same. The formula that we'll discuss with brevity, because of the fact that it's not something I need you to memorize, is the summation of all the values, where we take the X value, which is the data value, and we're using every single one of the data values. That's why we have the summation sign there. And X bar, you'll remember, is the symbol for mean of a sample. So we take those calculations and we're subtracting them and squaring it, and then we take the summation of all those calculations. And then on the bottom of the fraction we have n minus 1, the number of values minus 1, and then we take the square root of that entire thing. And once again, as I said, it's not necessary for you to memorize that formula, because this is all done technologically in calculators and Excel spreadsheets, etc. It's not necessary to memorize this formula at all. Rather, we're going to take a look at the applications of standard deviation as opposed to actually, doing all of the mathematical work associated with it. The standard deviation of a population changes slightly because of the fact that we have a population instead of just a sample. The formula here, a couple of things we'll talk about is, again, X is the data value. We're taking the entire population into account this year, not taking one of the values out. And mu, that funky letter U there, is called mu, and that's the symbol for mean of a population. The instead of S here for standard deviation of a population, we use the uh, small letter sigma. It's a Greek letter. That is the lowercase sigma. Again, not critical to memorize it because of the fact that we obtained this technologically. In fact, in the TI-84 calculators, it's going to be critical for us to be able to tell the difference between the sample standard deviation and the population standard deviation. Variance, we've discussed variation as meaning how do the data values vary amongst themselves? Is there a big gap? Is there a little gap? Are there several big gaps? Are there several little gaps, etc.? The variance of any set of data is a measure of its variation. Sample variance is the square of the standard deviation of a sample. And population variance is the square of the population standard deviation. The reason that this becomes difficult sometimes to use is that the variance is a square of the original unit. So we're going from units to units squared. It can be a disadvantage because now we're talking about different units. However, the biggest advantage to this is that sample variance becomes an unbiased estimator of the population variance. This means that typically as human beings we tend to estimate over or we estimate under. In this case, the sample variance is an unbiased estimator. It's tending to go exactly towards the population variance as opposed to over or underestimating it. The homework in this section is textbook pages 109 to 110, numbers 1 through 4, 6, 9, 12, 15, and 18. And again, I am not asking you to calculate the standard deviations by hand. I would much prefer you did it using the technology, whether you decide to use a TI-84 calculator or an Excel spreadsheet or any Google calculated websites. You can put a Google search in for a statistical calculator and it will work just fine.